What's up, everyone? Welcome to Michael P. IT. Today we'll be going over future with quantum computing. So let's get to it. Thank you for joining. So let's get into a scenario. Like, just imagine one day we wake up and everyone is discovering that every password, bank transaction, military secret, and encrypted message on Earth could suddenly be exposed. To us, that might sound like science fiction, but cybersecurity experts around the world are preparing for a very real possibility called the quantum threat. For decades, encryption has protected our digital lives. It secures online banking, military communications, healthcare records, cryptocurrencies, and even the messages you send every single day. But as quantum computers edge closer to reality, the encryption protecting our digital world faces an existential threat. Today we are going to break down what quantum computing actually is, why it threatens modern encryption, the global race for post-quantum cybersecurity, and what organizations must do right now to prepare for the future. This is one of the most important cybersecurity challenges for the next decade. To understand the threat, we need to first understand the technology behind it. Digital computers like laptops, gaming systems, smartphones, and server processes information using bits. A bit can only be one or two values, 0 or 1. Everything your computer does is built from billions of these tiny binary calculations happening at incredible speeds. Quantum computers are completely different. Instead of bits, they use something called qubits. Qubits can exist as 0, 1, or both at the same time. The strange behavior is known as superposition. Quantum computers also use another property called entanglement, where qubits become linked together in ways that classical physics cannot fully explain. What makes this powerful is that quantum computers can process enormous numbers of possibilities simultaneously, instead of checking one possibility at a time like classical computers. For certain types of problems, quantum computers can solve calculations in minutes. That would take modern supercomputers thousands or even millions of years. That sounds incredible for scientific research, medicine, artificial intelligence, and engineering. But for cybersecurity, it creates a massive problem. Modern encryption is the foundation of digital trust. Every time you log into a website, use online banking, send a secure message, shop online, or connect to secure Wi-Fi, encryption is working behind the scenes to protect your information. Most modern encryption systems depend on mathematical problems that are extremely difficult for classical computers to solve. One major example is RSA encryption. RSA security depends on the difficulty of factoring extremely large prime numbers. Classical computers will require an unrealistic amount of time to break strong RSA encryption using brute force methods. Another example is elliptic curve cryptography, which is used to secure web browsing, cryptocurrency systems, VPNs, and encrypted messaging apps. Again, these systems are considered secure because classical computers struggle to solve the mathematical problems efficiently. Right now, these encryption standards are trusted around the world, but quantum computing changes everything. In 1994, mathematician Peter Shor developed something called Shor's algorithm. The algorithm demonstrated that a sufficiently powered quantum computer could solve the mathematical problems behind RSA and elliptic curve cryptography dramatically faster than classical systems. In simple terms, future quantum computers could potentially break much of the encryption protecting the modern internet. That means attackers could theoretically decrypt classified government information, financial records, military communications, healthcare data, corporate intellectual property, and encrypted internal traffic. Cybersecurity experts sometimes refer to this future moment as Q-Day. Q-Day refers to the point where quantum computers become powerful enough to break widely used encryption standards. And here is the part of concern governments and security professionals the most. Attackers may already be collecting encrypted information today, so they can decrypt it later once quantum computers become advanced enough. This strategy is known as harvest now, decrypt later. Even if the cyber criminals or hostile nations cannot read the stolen data now, they may store it for years until quantum technology evolves. That means information being transmitted today could still become valuable in the future. For governments, defense organizations, healthcare providers, financial institutions, and large corporations, this is an enormous national security and business risk. The good news is that cybersecurity experts are not going to ignore the problem. Around the world, governments, universities, and major technology companies are racing to develop post-quantum cryptography. Post-quantum cryptography refers to encryption algorithms specifically designed to resist attacks from the quantum computers. One of the leading organizations in this effort is the National Institute of Standards and Technology, also known as NIST. NIST launched an internal competition where researchers from around the world submitted quantum-resistant encryption algorithms for testing and evaluation. These algorithms went through years of analysis, stress testing, and peer review to determine which approaches could survive future quantum attacks while remaining practical for real-world systems. Several algorithms were eventually selected as future standards for post-quantum encryption. Major technology companies, including Google, Microsoft, IBM, Amazon, and Cloudflare, are already testing and implementing post-quantum security technologies. Governments and military organizations are also accelerating mitigation plans because some encrypted information must remain secure for decades. This transition represents one of the biggest cybersecurity transformations in modern history. So what should organizations actually do right now? Experts say preparation needs to begin immediately because migrating global infrastructure away from vulnerable encryption systems could take many years. The first step is identifying cryptographic assets. Organizations need to understand exactly where encryption is being used throughout the environment. This includes websites, VPNs, cloud systems, mobile applications, IoT devices, databases, internal communications, authentication systems, and secure APIs. Organizations cannot protect what they cannot identify. The second step is developing something called the crypto agility. Crypto agility means building systems capable of changing encryption methods quickly and efficiently. Instead of designing systems that rely on one encryption algorithm forever, organizations need flexible architecture that can adapt as new standards emerge and threats evolve. The third step is beginning post-quantum migration testing. Many organizations are already experimenting with quantum-resistant algorithms in test environments to understand how these new technologies impact speed, compatibility, scalability, and performance. This migration will not happen overnight. The internet itself was built over decades, and modern infrastructure is deeply interconnected. Replacing runnable cryptography across the global digital ecosystem will be a massive undertaking. The final step is training cybersecurity professionals. Future security analysts, network engineers, architects, risk managers, penetration testers, and incident responders will all need at least a basic understanding of quantum threats and post-quantum cryptography. This includes many students watching this video right now. Quantum computing could revolutionize medicine, scientific research, artificial intelligence, climate modeling, and advanced engineering. At the same time, it represents one of the greatest cybersecurity challenges humanity has ever faced. The encryption systems protecting our digital world were never originally designed for quantum scale computational power. That means the transition toward post-quantum security is not optional, it is inevitable. The organizations that prepare early will significantly be more secure in the future. The cybersecurity professionals who understand quantum threats today may be some of the most valuable experts of tomorrow. The quantum era is definitely coming. The question is not whether cybersecurity will change, the question is how prepared will we be when it does. If you enjoyed this cybersecurity breakdown, make sure to subscribe to Michael PIT for more videos covering cybersecurity, networking, ethical hacking, and security plus concepts, threat intelligence, and emerging technology trends. Thank you for watching and stay secure.